Good morning, children. So welcome back to the online session of your mathematics class. So we know that we will be discussing about the lesson circles. So in that exercise 4.2. So in the last class we have discussed about 12th question. So in today's class we will discuss about the 13th question, which is the last question in the exercise 4.2. So if you complete this will complete the lesson. So we will do some examples whichever you feel difficult in that lesson. Then we will go for the next lesson. Okay. So we will discuss about the last question. This is prove that opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of a circle. Prove that opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of a circle. What do you mean by supplementary? If you add those two angles, that must be equal to 180 degrees. So which two angles you are going to add? The angle subtended by the opposite sides of a quadrilateral at the center of a circle. At the center of a circle. So you need to connect opposite sides in the center of a circle, right? Okay. So now this is the angle. This is the angle subtended by one of the side at the center. At the center, we make one more opposite side, right? So now this is the other angle subtended by the opposite side at the center of a circle. Now, according to the question, we need to prove that opposite sides of a quadrilateral circumscribing a circle. These two are the opposite sides, right? AB and CD are the opposite side. Subtends supplementary angles at the center of a circle. Subtends supplementary angles at the center of a circle. That means, so this is the angle formed by this side at the center. So this is the angle formed by the other side at the center. We need to prove that these two angles are supplementary. These two angles are supplementary. How to prove that these two angles are supplementary? So adding these two, which is this angle AOB. So angle AOB. This is COB. COB, which is equal to 180 degree. We need to prove that these two angles are 180 degree. Then we can say that opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of a circle. So these two angles are going to become 180 degree. If you prove that, then this will complete the theorem. Not only these two, of course, these two sides are also a opposite sides, right, of a quadrilateral. Then these two angles is also, sum of these two angles is also 180 degree. That we need to prove that. We need to prove that. Okay. So by using the concept of length of tangents as well as adding some of the angles, we will do that. So this is the circle, and this will be a quadrilateral circumscribing a circle with the point of contact. These are the 4 point of contacts, right? Let me take this P, Q, R, S. Okay. So we join P and O. Then O and R, these two. Okay. So now I'll make it as a big angle, then we will come to know that. Okay, mark it here. So we need to prove that this angle is equal to this. That is angle AOB is equal to COD. This is O. Well, that's it O. Okay. Now, in order to avoid the confusion, let me call it as this as angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. In order to avoid the confusion. So this is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle 5, this is angle 6, angle 7, angle 8. Okay. I will be to avoid the confusion. I will be taking angle between AOP as 2, angle between SOA as 1, angle between POD as 3, then angle between POQ as 4. We will be assigning as 1, 2, 3, 4, 5, 6 to avoid the confusion. Okay. So what we need to do that in order to AOP plus COD, AOP in the sense it is AOB, that is 2 plus 3. Angle 2 plus 3 will be equal to angle 7 plus 6 because COD will become 7 plus 6. So angle 2 plus 3 plus 7 plus 6 will become 180 degree. That we need to prove that. Okay, so we will prove that by using the concept of congruency as well as the length of tangents. Right? Now let me write that let ABCD be a quadrilateral circumscribing a circle where ABCD be a quadrilateral circumscribing the circle with center O. Okay, so that is the first statement. Then such that it touches the which is circle touches the quadrilateral touches the circle such that it touches the circle at P, Q, R and S. Circles points P, Q, R, S respectively. Okay. So respectively, let us join the vertices of the circle. Okay. Now, so let ABCD be a quadrilateral circumscribing a circle with center O such that it touches the circle at P, Q, R, S. This is quadrilateral which touches the circle at P, Q, R, S. We have assigned this angle. Okay. Let me prove that now. In triangle, I take these two triangles. Only these two triangles, which is that AOS, then AOP, or SOA, or POS. We will take AOS only, AOS, AOP. Okay. RS, we can take SOA also. SOA, then POA. In triangle, SOA and triangle POA. I'll take POA. I'll take these two triangles. I will prove that these two triangles are congruent. Then I am able to say that these two angles are equal. If I say that these two angles are equal, then angle 1 is equal to angle 2. By using that, I am able to obtain some relation. Then similarly, I can prove that these two are equal because these two triangles are congruent. Then I can say that angle 3 and angle 4 are equal. Then again I can say that these two triangles are congruent. Okay, then angle 5 and angle 6 are equal. Then I can say that these two triangles are congruent. Why only these two triangles are congruent and these two are not congruent? Because only these two triangles are congruent. Because see, observe that AS is the length of tangent, AP is the length of tangent. With these two are the tangents drawn from the same external point, right? So therefore A is equal to AP. Then AO is equal to AO, right? Then OS is equal to OP. Then all the three sides are corresponding sides are equal. Whereas if you take these two sides, then you can say that OS is equal to OS. But other two sides you are not getting. Either OA is equal to OD, that we don't know that. A is equal to DS, that is also we don't know that. We don't have a condition. But whereas for these two triangles, we have all these three conditions. So by the triple S rule, I can say that these two triangles are congruent. Similarly, these two triangles are congruent. But I will not say that these two triangles are congruent because I don't have conditions for that. Similarly, these two triangles are congruent because C is the external point, CR and CQ are the tangents. Those must be equal. Similarly, these two triangles are congruent because D is the external point, DS and DR are the length of tangents drawn from the same external point D. Okay. So I have taken these two triangles now, SOA and POA. Okay. So in that triangles, we know that A is equal to AP. A is equal to horizontal triangle radius. OA is equal to OP. OS is equal to OP. The reason is radii of same circle. Radii of same circle. Okay. Then OA is equal to OA. OA is equal to OA, comma. Right? OA is equal to OA, comma. Then A is equal to AP. A is equal to AP. A is equal to AP because those were tangents. Tangents on a circle from point A. From point A. Tangents on a circle from point A. So you know that between these two triangles, all the three corresponding sides are equal. Therefore, I can say that triangle SOA congruent to triangle POA because these three conditions are satisfied. By the triple S rule, all the three sides of one triangle is equal to the corresponding three sides of other triangle. Therefore, these two triangles are congruent. Therefore, I can write triangle SOA congruent to POA by which rule? Triple S rule. Okay, from the triple S rule I can say that these two triangles are congruent. This SOA, then POA. If those two triangles are congruent in the sense, corresponding angles and corresponding sides must be equal, right? Therefore, these triangles must be equal. These triangles must be equal. These triangles must be equal, right? So therefore, these triangles are equal, right? So I can write that what is that? Angle SOA. Angle SOA is equal to angle POA by CPCD. By CPCD, SOA will be denoted as 1, POA will be denoted as 2. We will write angle 1 is equal to angle 2. Call this as equation 1. Call this as equation 1. We have proved that angle 1 is equal to angle 2. Right? So we'll go further. Okay. Now, similarly, these two triangles are congruent. These two triangles are congruent. So that we can write that we don't need to prove that. We can directly write. Similarly, we can prove that. Angle OPB congruent to OQB. Then corresponding angles are equal. Therefore, angle 3 is equal to angle 4. Right? So similarly, we can prove that. Angle 3 is equal to angle 4. Call this is equation 2. So angle 3 is equal to angle 4. So angle 3 is equal to angle 4. Then angle 5 is equal to angle 6. Angle 5 is equal to angle 6. That is equation 3. Then angle We will keep these equations, and we know that sum of all the angles will become how much? Sum of all the angles will become. So this is a circle, right? If you take the circle, then what is the angle of that circle? It's a complete angle. How much it is? 360 degrees. So therefore, if we add all these angles, that will become 360 degree. We'll write that angle 1 plus angle 2. We go to write that we know that angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8 is equal to 360 degree, because it's a complete angle. If you take the full rotation, which is a complete angle, the total angle will become 360 degree. A circle, the complete angle. How much is the complete angle? It is right 360 degree, right? Now, so angle 1, angle 2, both are equal. So I can take angle 1 is equal to angle 2. Angle 1 is equal to angle 2. So we should take AOB, angle 2 is equal to angle 3. Okay. So we will take angle 1 is equal to how much? Angle 2. So in the place of angle 1, I can substitute angle 2. So I can substitute in the place of angle 1, I can substitute angle 2, because angle 1 is equal to angle 2. We'll write angle 2 as it is. Okay. Now, angle 3. I will write angle 3 as it is. Angle 4 is equal to angle 3. Angle 4 is equal to angle 3. So in the place of angle 4, I am substituting angle 3. Okay. Then, angle 5 is equal to angle 6. Angle 5 is equal to angle 6. Plus angle 6 I am writing as it is. Right? Then, angle 7 I will be writing as it is. Then angle 8 is equal to angle 7. It's equal to 360 degree. Right? So angle 1 is equal to angle 2. From equation 1 I have substituted. Angle 2 is as it is. Angle 3 I have written as it is. Angle 4 is equal to angle 3. From equation 2, angle 4 is equal to angle 3 I have substituted. Then angle 5 is equal to angle 6 as it is I have written. Then angle 6 is equal to angle 5 from the equation. Angle 5 is equal to angle 6 from the equation 3. So angle 6 is equal to angle 6 as it is. Then angle 7 is equal to angle 7 as it is. Then angle 8 is equal to angle 7. Substitute from the equation 4. Now you can observe that angle 2 plus angle 2 will become 2 times of angle 2 plus these two. Angle 3 plus angle 3, that is 2 times of angle 3. Angle 6 is equal to angle 6 plus angle 6, that is 2 times of angle 6. 2 times of angle 7 is equal to 360. Okay. So now what is the common factor? 2, 2, 2, 2 will be the common factor. I can take it from the outside as a common factor. So 2, angle 2 plus angle 3, I will make it 8. Angle 2 plus angle 3, I will make it 8. Okay. Plus, so 2 I have taken common factor, angle 6. 2 I have taken common factor, angle 7. I will make it as these two as 1k is equal to 360 degree. Here. Now 2 is multiplied here. 2 into angle 2 plus angle 3 plus angle 6 plus angle 7. So 2 is multiplied. If you send 2 to the other side, it will get divided. So angle 2 plus angle 3, then angle 6 plus angle 8. This is another pair, which is equal to 360 degree divided by 2. 2 will be divided. So angle 2 plus angle 3, which is angle 2 plus angle 3, we can observe that angle 2 plus angle 3. Angle 2 is angle AOB, this is AOB, this is POB. So angle plus angle 3 will become angle AOB. Angle AOB. So this is angle AOB, which is angle 2 plus angle 3 will become AOB plus angle 6 plus angle 8. Angle 6 plus, angle 7 this is. Angle 6 plus angle 7. Angle 6 plus angle 7. What is that? COD. Angle 6 plus angle 7 will become angle COD. So this is COD. Which is equal to 1 is 180 is 180 degree. So this is what we need to prove. Angle AO is equal to angle COD, which is 180 degree. That is what we have proved, right? So this indicates that a circle. So this indicates that opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of a circle. So we have proved that opposite sides subtended angles subtended at the center will be supplementary, that is equal to 180 degrees. So these two are the opposite sides. So angle subtended at the center will become 2 plus 3 for this side. For this side, this is angle 6 plus 7. So those two will become 180 degree. So similarly, not only that, these two angles is also 180 degree. Angle 1 plus angle 8, angle 4 plus angle 5 will become 180 degree. That is also true. But also we can write what is that angle. Similarly, we can do that angle AOD is equal to angle BOC or COB. I'm sorry, not equal, plus is equal to 180 degree. Supplementary, right? So these two are the opposite sides. Those two opposite sides of a quadrilateral subtends at the center of the angle will be supplementary. So these two are the opposite sides. Those two sides will subtend the angle at the center will be supplementary. Okay. So from these two conditions it is satisfied. Okay. So that's it. From these two conditions we prove the theorem. Okay. So this will complete the lesson. So in the next class, we will go for some examples and we will solve some examples, important examples from this lesson. If you complete that, then we will complete the lesson. Then we will go for the next lesson. Okay. So if you have any doubts in this question, you can put a message or you can call me. So that's it for today's class. Thank you. We will meet in the next video.